There you go. Say hi, Danielle. Hi. All right, take it away.
All right, thank you very much. Good afternoon, everyone. Welcome to the, well, boy, what day is it today? February 6th version of the HamSCIence Zoom call. Uh, Good to see so many in attendance. Um, it's good to see such an international representation, especially in these times where our so-called elected politicians are more interested in throwing flaming arrows back and forth than cooperating as humans should. So it's a nice thing for the amateur community to be able to put all that stuff aside and enjoy each other's company.
Hey,
Very,
Gary.
very important. Yes.
Yeah, it was that universal appeal of music that started this off.
That's true. And I remember, I think I may have said it before on some of these calls. I remember when I was a teenager and on 75 sideband with a bunch of my other high school buddies from around the state. A lot of people were involved with music and band and also that sort of thing. I never was, but for some reason there seems to be something about rhythm and ham radio and musicians that just seem to go together. All right. Well, we'll get started with today's program on 6 meters and sporadic E. Ken, I'm not sure how long you've got the hour if you need it. We obviously like some time for questions and answers at the end. That would be great. So what we're going to do today is I'm going to display the slides and I'm going to advance them for Ken, and he's here on an audio channel. So if you guys are ready, we'll get started. Ken, are you ready?
Yep.
Okay, I will share, folks, and here we go. Off to the races. Ken, it's all yours.
Okay. This is my standard opening slide. I just made it. That date is the date that I made the slide. So for this meeting. So next slide, please. Okay. This picture of me at a talk I gave probably about 10 years ago. And on the right are two publications that I did for ham radio, one with World Radio that's no longer with us, and the other one is CQ. The top one is 6 meters, a guide to the magic band. It went into 4 edition, and we had a lot of fun doing it. And the book on the bottom there, VHF Propagation, I co-wrote with Gordon West, WB6NOA, and it went into 2 printings. The last printing, unfortunately, happened about a year before CQ magazine basically met its end forever. But I do have copies of the 6 meter book if anybody's interested. The other one, if you find it, you might find it at some ham flea market or a friend. So one of the things that I do, typically I do 1 to 2 talks a year. I usually do 1 talk in January at a thing called Ham Radio University, which is held at one of the colleges in Long Island, and they have a format of 5 forums going on at the same time. Forums are about 40 minutes plus question and answers. So I've been doing that particular thing, Ham Radio University, for over 20 years, back into the last century. So typically about 6 meters or things related to 6 meters. So the next slide, please. So a common terminology for 6 meters, it's called the magic band. Got that moniker probably about 30, 40 years ago. Typically it's very quiet most of the time, but it is one of the best bands to observe propagation because it's so quiet. When propagation happens, like sporadic-E or aurora or any of the other modes listed there, you can, it just brings it to life, and you can actually understand propagation a lot better by hearing it on 6 meters, because you go on a busy band on 10 meters or something at this time of the solar cycle, there's a lot of stuff happening that makes it a little tricky to really nail down propagation modes. Next slide, please. So one of the big things that has been happening, that first sentence is I didn't update, but it there has been some F2 activity on 6 meters, We had some in October and November of 2024, and there's a good possibility we'll see some more in the fall of 2025, depending on how the sunspots behave. The sun is always full of surprises, but the main mode of propagation year in and year out is sporadic-E propagation. It's a skyway propagation mode that is very common during the months from May into early August. For those of you who used to have TV sets hooked up to antennas, there used to be your famous cross-channeling interference. So you'd be watching your local station, and a station from 300 or 400 miles away would be coming in on your channel 2 or channel 4 reception. So it is a very, very interesting propagation mode. It's also observed on 10 meters, but sometimes it gets missed because of all the other activity on 10 meters sometimes. Next slide, please. So believe it or not, hams were the first group to discover the sporadic-E phenomenon. Back in 1935, when we had the 5-meter band, we didn't have 6 meters until after World War II. Formations occur about 70 miles or 100 kilometers above Earth in the E region, and typically can reflect radio waves as low as 28 megahertz up to 200. I have never worked any sporadic-E on 220, but I have on 2 meters, 2 big openings in my lifetime. And it is called sporadic-E for a reason, because you have formations that last as little as 5 minutes to as much as several hours. And because the formation is non-uniform, you get a lot of fading, and then you get a lot of peaks. And it's pretty effective to use QRP power during a strong sporadic-E opening. And as I said, the major season for it is May to June, and it's kind of a minor winter season from November to January. From May to June, or like June and July, you could see 20 days of sporadic-E activity on 6 meters on average during a good season. With the minor season in November, December, and January, and even February, you might see 2 to 3 a month. I just had a opening. I worked a ham in Florida on February the 1st in the afternoon a few days ago. Not particularly common, but it's not super rare either. Next slide, please. There's been a lot of studies into sporadic-E, probably because of the TV interference problem with broadcast TV back in the 1960s. And they used to launch rockets into these active sporadic-E formations. They were able to measure the ion composition. A lot of these are published in works like the Space Research series that started in 1963. And also there's actually a book on sporadic-E by Dr. Ernest K. Smith, who did a lot of studies on it. And so you have metallic ions in there, typically iron, magnesium, nickel, silicon, sometimes aluminum. And all of that is from meteor ablation into the Earth's ionosphere there. And so you have these metallic particles, and then when they combine with oxygen ions that are present in the E region that get excited because of more solar radiation in the summer months, you get metallic ions. And it's like an invisible mirror in the E region, but it's non-uniform. It's like a sponge. When I do actual talks, I always bring my sponge along to show how these things kind of look. When the formations get denser, when there's a lot more ions per cubic inch, they can reflect higher frequencies. It doesn't happen as much but you can get into 2 meters once in a while. I've had a few during the month of July, and that's being here in North America. The paper I wrote for QEX recently with another science professor from Dayton was concentrated on the high amount of sporadic-E activity in Southeast Asia, like Japan and China and Korea. The formations can go very high in frequency, very easy to reach the broadcast band, like 80 megahertz FM, and they do go into 2 meters. It is hard to get a lot of ham observations because of the language barrier, but I think it's well known that it gets pretty high there in the summer months in that part of the world. Cool thing about sporadic-E is independent of the solar cycle. So you may have some better seasons than other, but sporadic-E will always show up in the summertime in the in both the northern and southern hemisphere. Next slide, please. So here's a very crude representation of a single hop sporadic-E skip. For 6 meters, usually 700 to 1200 miles per hop. The thing I gotta mention, polarization isn't especially critical because the waves rotate as they come off the sporadic-E formation. So beams are still good though, because you get more concentration of signal strength from a beam as opposed to vertical. But you can work stations using a vertical with not much trouble. I haven't listened to FT8. This is an older slide, but pretty much all modes can be used for sporadic-E. Next slide, please. So I'm in the red dot, which is Long Island, New York. So that's the coverage on a typical single hop sporadic-E from my area. We can work into Tennessee, into Florida. In the Midwest, we could work all the way up to Michigan, Minnesota. So that's kind of like the coverage that you can get with some minor variations. The next slide, please. So what makes sporadic-E even more interesting is double hop sporadic-E. This, again, is also a very rough graphical representation. A lot of people argue that it doesn't really come back down to earth, but I don't really have any way of knowing if it does or doesn't. But with double hop, you can pretty much double your coverage. And you can see that in the next slide, please. So from Long Island, I can work into Arizona with not much trouble, often Nevada and California, Idaho. And as you go towards the east, you start to hit some places like the Azores and islands in the Atlantic there. Next slide, please. Now, during the summer, you can have many sporadic-E formations all over the place, sometimes as much as 5 or 6 in a day if you had everybody truly measuring it. So the big thing for people on the East Coast is to work into Europe during the months of June and July. That's usually 3 to 4 hops. And this past summer wasn't too good. With that many formations, it's very hard to predict, you know, if you're going to be able to work Europe, but you just listen every day and do the best you can. So it can occur anytime between May and August, but June and July is statistically the best month for multiple hop sporadic-E. And you can work into Western Europe. sometimes the Midwest can work into to certain places, and they can also work into Western states can work into the Japan in June and July. That could be 3 to 4 hops there. On a good summer, you might get 5 to 6 transatlantic openings between the east coasts of US into Europe. Some summers may be better, some will be worse. And as I said, it's not affected by the solar cycle. So even in a very low solar flux year, sporadic E activity still continues to be good. And you don't need very high power. My station, I can run 10 watts or 150 watts. And then when I do QRP work for the VHF contest, I use 10 watts with a 3-element beam on a hill, and I can do pretty good. Next slide, please. 2021 was a very good year in the summer months. I've used this slide in some other presentations. So I had openings as early as May that year, and it went into, I'm looking at it, July 22nd. So you could see the areas I was hitting, Southern Europe, Western Europe on a couple openings, like with Britain and Belgium and a few other locations, Italy and some places, France. So that was a pretty good summer. And most of those I worked on CW and sideband. I don't use FT8 here. That's just a preference. Next slide, please. So through my various correspondence, I came across a scientist in Sweden that referenced one of my papers, and I got this ice cap radar plot from Sweden, and you can see, if you look at time on the right-hand axis, it started around 1350 UTC time, and it goes all the way up to 1600. You can see how the formation is very broad at the very beginning, and then towards the middle, it gets very sharp. One characteristic of a sporadic-E formation is, besides being very dense, it's also very thin. Typically less than 100, probably less than 20 kilometers. So it can get very thin, and then eventually it starts to break up. It gets a little broad. And you could see that it was thin for about a 15-20 minute period in this plot. And that was probably, that would be its maximum efficiency when it gets like that. You can see on the left-hand side is the amount of particles per, it's like millimeters cubic millimeter. So you could see the density went up too in the middle of the plot as well. So that was kind of fun to get this. Next slide, please. So the big question for years is what causes sporadic-E? And one of the things I've learned, a lot of scientists do not like hams because hams come up with these theories that are not supported by things. And there was a theory that thunderstorm activity used to be a part of the process for forming sporadic-E. But as most of you know, thunderstorms tend to be less than 10 to 15 kilometers above Earth. And sporadic-E is at 100 kilometers. So there's really no direct correlation that's obvious. As I mentioned before, during the summer, the oxygen ions combine or recombine with neutral metal particles to form metal ions. And during the summer months, you have more solar radiation, so it creates more oxygen ions. There's a factor called wind shear in the E region, winds from different directions that can compress these ions into thin layers. So when they get compressed, as we saw in the previous graph, it's maximum reflection capability. I consider sporadic-E like a invisible metallic mirror in the E region. You know, we can't see it, but it's there during the summer. Eventually, due to the effects of tidal wave and gravity, these formation push down towards the Earth and they break up. Some ions return back into the E region, but a lot of them oxidize and they fall to Earth. Next slide. So here's a picture of that theory. This is not proven or anything, but it's a rough idea of what's happening. You have metallic particles coming from meteor ablation, and they're coming down into the E region, which is in this graph between 90 and 100 kilometers. And you have the recombination effect with oxygen ions. And you have particles going two ways. They either go down to Earth after the formation breaks up, and in some cases they go back up in the E region due to wind activity, and they become available again in the future. If I had a lot more instruments, I would have colored coding for these sporadic-E clouds so we can track them. Next slide. So, cool thing is, in one of my earlier papers, I used to get ionosound data from different ionosound stations. These ionosound stations have been around since the early 50s. Basically, it's a station that sends a radio or energy up to straight up vertical, and whatever reflects back, they can measure what formation. So not only can they measure sporadic-E, but you can also measure any F layer activity as well. When I used to use data for one of my earlier papers in 1996, the data from ionoson was only hourly, once every hour, and the most popular station in the US was Boulder. We've had some in Eglin, Florida, and also Millstone in Massachusetts, and Wallops Island in Virginia. And as you can imagine, with improvement in technology, there has been better resolution where the data will be collected at 5 and 10-minute intervals. And it's also available on the internet. There's a website, GIRO, that is sponsored by Lowell, Massachusetts college there. The MUF for sporadic-E formation is that a rough formula is 5.33 times the critical frequency, which is FOES. So if you are getting a reflection on 6 meters, 5.33 times, say 9.5 will get you there, you know, because the FOES is a vertical and the 5.33 is kind of like your MUF calculation. So I showed that on the bottom there. Sporadic-E is also common on 10 meters, and it's very pronounced when you hear it in the wintertime. Next slide, please. Here's a plot from an ionoson station captured from Aicheon, Korea. The bottom formation, you can see it's going all the way up to 14.15. Now, if you multiply that by 5.3, that puts you right on the bottom of the FM band. Unfortunately, they are limited, a lot of these stations, at 15 as the maximum FOES. But it's possible a lot of these could go even higher, up to 2 meter range, 144 megahertz for maximum frequency. So this is typical plot, It's from the Lowell Gyro Data Center. It's easy to find on the internet. And I've been using it, and I've been using it for the recent QEX paper. Next slide. So one of my early paper was in 1996 published. I was using this data mailed to me from Boulder on those old 3.5-inch disc, and I used to have to print them out and do all kinds of plotting. So I used stuff from Boulder, I think some from Hobart, Australia. And this paper has been quoted by a few people. Most recently by this science professor in Dayton, Ohio, and I made a connection with him. And he had data that he collected through radio occultation data that's used in GPS applications. So we found a common ground with sporadic-E, but from different perspectives. So that paper in QEX was a nice combination of these two perspectives. Next slide, please. Yeah, I did a talk last year in one of the local clubs, and I bring this sponge along. And I'm right there, I'm compressing the sponge. I bring the sponge to show it that a sponge is not uniform, and there's a lot of holes in it. That's essentially kind of like what a sporadic-E formation is. It's non-uniform. And if you push on it, it becomes thinner and also more dense. And when it becomes denser, it can reflect higher frequencies. So that was a cool picture. Next slide. What's also cool about sporadic-E combines with other propagation modes. So in the equinox period, like late April, early May, and late September, early October, you have transequatorial propagation that goes from Argentina into Florida, southern part of Florida. And those people will work stations like that many times during the week in the late afternoons from 4:30 up to 5:30 local time. So how do people further up north take advantage of that? Well, the formation on the right, sporadic-E cloud links up just right with a station in Florida in that general area. And I have worked a number of stations in Argentina by that methodology. This one was an old opening from 2002. And I believe I did that from my car with a vertical antenna and about 40 watts. Next slide, please. This one was a really great opening. Again, it was TEP, and I worked more than the 3 stations here, but these 3 represented 3 different countries. And that coverage there kind of like represents the sporadic-E mapping or filter that comes through further up north. So there was pretty good coverage there. I used this slide in a talk at the National Ham Convention in Hartford in 2015, I think it was. And HamCE3SX showed up at the end of the talk and said, "That's me." So I thought that was fun. Next slide, please. This book, if anybody's interested, you can write me an email. I have many copies of it. This is the last edition that came out in 2008. It's out of print. World Radio is out of business. And it has a lot of these diagrams that I showed you in this presentation. And it's out of print, so it's got kind of a cult feeling. And I think that is the last slide. I'm not sure. I think that's it. Yeah. So I'm sure there's some questions. So I've got my pen and paper ready.
All right, any questions for Ken? That was very interesting. Very well
Yeah.
done. Thank you. I'll leave the slides up in case somebody wants to refer to any of them.
Sure.
This is David McGaw. I'm at Dartmouth and do research, and I'm particularly interested in sporadic-E. There was a report just today, I guess it was, on Starlink having a number of satellites deorbiting far more than they were expecting. Do they feed the sporadic-E layer?
What altitude are they at typically?
Well, they're way up there, and then they're coming through and burning up.
Okay. Yeah, because unless they're in line with the formation, I don't think they would see it or not.
Yeah.
But it could be an interference mode in some cases.
No,
Yeah,
I think,
they
I
were
think
saying
he's, I think the question is a little bit different. If I understand the question correctly, David, you're saying that when these satellites deorbit, that is, burn up in the upper atmosphere, do they contribute to the creation of sporadic-E? Is that
correct, right?
Oh,
Because
yeah.
they're saying that they actually are detecting their burning up their burn-up products in the upper atmosphere. NASA's flying upper level aircraft and detecting aluminum and whatnot, presumably because there are so many of these things burning up now.
Right.
Yeah.
This is Ed. I wanted to also comment on that because the metal ions from the satellites burning up were greatly increasing in the upper atmosphere, and this is a perfect test for seeing if metal ions are directly involved in sporadic-E.
Yeah, it's not much different than the meteorite or meteor
Yeah.
dust.
It would be more like a meteor scatter type thing, MS. And
Well,
so
but
when
meteor
probably-
dust is feeding sporadic-E, I thought.
yeah, well, you have a trail, but and usually the stations work off the trail and the reflection.
Well,
But I don't see this as being a very long-term event, though. It's probably less than 30 seconds if I had to guess. But that sounds interesting.
yeah, the other question I had had to do with the oxygen ions, otherwise known as ozone.
Yeah.
Also, does that tend to follow particularly strong weather patterns?
I don't think so because we're talking about 100 kilometers. So when you say weather pattern, I'm assuming you mean like thunderstorms and
Right, strong fronts and such.
Those things like fronts would be what you would see in tropo openings that show up on 2 meters.
Right. Yeah, there is that, of course.
But the ions pretty much are created during the solar radiation in that region, particularly during the summer.
Thank you.
You're welcome. Any other questions?
Hi, Ken. Very informative talk. Thanks. In your starting slides, somewhere you had touched upon the polarization part, which gets affected because of the sporadic-E. Can you say what was it? In terms of polarization, you had something. Yeah, something related to polarization you had here. Polarization of the radio waves get affected differently with the sporadic-E?
I think it's one of the earlier slides, isn't it?
Yeah, earlier slides. Yeah.
It was like the next.
A passing comment that polarization of the radio waves were differently or supposed to behave differently because of sporadic-E.
You're saying vertical versus horizontal polarization may propagate differently? Is that the?
I did not get what that polarization. Yeah, Ken.
You have the Faraday rotation effect because that one. Because when it reflects off the formation, the orientation can change. However, most people usually use beams just to get a little more punch in the direction that you want to work. But you can work pretty much vertical to beam and whatnot because it's a skyway propagation. Just like an HF band, you have dipoles working beams, right? it'd be pretty much the same effect.
Okay.
So is the thought that the polarization may change? It may leave the antenna either horizontal or vertical, but then undergo a rotation. And at the receiving station, it could be a different polarization. Is that correct?
Yeah, but a lot of people use the beams because they get the maximum gain in the direction they're pointing, but the polarization isn't too critical as it would be, like, say, with a line of sight or a tropo opening. You would want to be matched in that case. This,
Yeah, interesting, Ken. If I can just chip in and just say that I think what you've described is that there is a really noticeable difference when you're operating between a single hop sporadic-E event and a multi-hop one, whereas the multi-hop one that will involve a relatively lossy interface somewhere, whether it's over the sea surface or over the land, where it comes back down again. And therefore I've found over the years that beams, as you hinted, are very useful for those multi-hop paths, and you probably wouldn't do very well on a vertical or a screwdriver in the back of the aerial socket, whereas you can on a single hop one do remarkably well with very little effort in the antenna department at all, and it behaves quite differently.
Yeah, I agree. But I didn't put in this presentations, but I had some days where the multiple hops were just so strong because there were many formations and they were dense that there wasn't a lot of fading, but most of them tend to have fading and they're not terribly long. They could be 10, 15 minutes. So it's a lot of fun though, chasing them for sure.
Yeah, certainly. I mean, if you think how many moving parts there are, you know, there's the ease layers themselves slowly descend, and they're not flat surfaces; they're undulating surfaces as well. It's a miracle we make any contacts at all, I think, with multi-hop paths.
Yeah, well, I think we need more measurements in those areas and more instruments that are capable. But what I think happens, I'm like looking at my circular pool, and if you look at it, all these dirt particles always seem to end up in this middle of the pool over time. And I just think particles kind of collect together in the E region because of wind. The winds aren't consistent, so you get these little slow areas, which may be like a vortex type thing for particles to collect. So there's so much that we don't know. We're kind of like looking at the aftermath, of an opening, and we have a rough idea of what we think causes it. But there's so much more research that can be done.
It's worth following up. You mentioned tidal winds. It's worth following up any information on that, Ken, because I think that controls a large part of the time of day, and then the weather stuff. Sitting on the weather fence, I have to say that even though thunderstorms cap out in the troposphere, the significance of them on occasion, they're very small contributors because most of the time they move fairly quickly, so they're not in one place producing the results for a consistent period of time. But where they are there, what they do, they generate like a gravity wave undulation in the air currents that can propagate up to the E region. So although they are, quite rightly, as you say, a long way below sporadic-E, the disturbance of the wind pattern can propagate between the two places. So there could be a link which might explain the thunderstorm thing, but it works better for jet streams if you're looking at weather things, or in other words, weather fronts.
Yeah, well, there is possibly a indirect correlation. So it's almost like a capacitor, right? So you have two plates. You have the troposphere and then you have the E region. So it's that area between the capacitor, right? Like the cream in the Oreo cookie. So there's a lot we don't know, but it could be some kind of reactive or capacitant like effect there. But yeah, the waves if there was such a thing, the waves would fit into that very much. So
The other thing you mentioned, China, which is an interesting observation over there in Asia, because you've got that huge landmass of the Himalayan and the Tibetan plateau, and you will very often in the atmosphere sense get very big standing waves, which, unlike thunderstorms, which move their effect along with the storm cloud, a standing wave set up over a mountain is very effective at setting up these gravity wave disturbances that can go all the way up to the E region and affect the formation of E's, which is, I suspect, got a lot to do with why they have such fun over there.
yeah, well, believe it or not, the lowest incidence of sporadic-E, particularly during the summer months, is South Africa. But what's in there is the SAA, the South American anomaly. So that's an inhibiting factor to sporadic-E for some reason. But it's amazing. I've been studying ionoson data because they're consistent, and I'll find very low sporadic-E activity during the summer, just occasional. And
Are
it
you
doesn't
talking
go
about their summer, Ken, or our summer?
all the time.
All right.
All the time. I look at many years worth of data, and so they have 3 ionosons in South Africa, one near Johannesburg and 2 others in other locations, and it's pretty low incidence of sporadic-E. Yeah, and a station in Falkland Islands, which is just outside the South American anomaly, will have regular sporadic-E during the summer. So there's a lot about the Earth where it's non-uniform. The Earth is a non-uniform sphere. There may be things like metallic, not ions, but metallic material beneath some of these locations that create these zones. There's so much that we don't know, and I can only guess, but it's a well-known fact. It's South Africa is the worst area for sporadic-E activity, whereas Southeast Asia tends to be better.
Yeah, well, I was thinking the other day when somebody pointed that out about South Africa, and that is in Europe and in the States, you've got huge numbers of people in most directions that you can talk to on sporadic-E. But if you're sat in South Africa at the sort of distances you need, everybody's in the ocean around the tip of the continent there, and there aren't many people to come up and report sporadic-E QSOs, which is a shame for them. It's a pity they miss out because of the geography.
Yeah, but I don't need hams because I have ionoson stations in South Africa, so I can get the FOES values like what's circled on this picture here, and they're typically lower than 5 during the summer.
Yeah.
So it's pretty bad, and the SAA zone is possibly a contributing factor, but there needs to be more data to really say that is or it isn't. But the ionosons are my true soldiers because they operate all the time, 24 hours a day. So I don't need hams sometimes.
Yeah, no substitute for good measurement. You might like to find I recommend you have a look at a plot of the location on a map of the geomagnetic equator and how that behaves over South America. That might be pushing the zone where sporadic-E happens, displacing it much further away from the geographic latitude bands that you normally associate sporadic-E to be, because you can't make sporadic-E over the geomagnetic equator, I believe, or at least you don't have the angle right for the inclination of the magnetic field compared to the horizontal. So the latitude bands either side of the geomagnetic equator are the preferred zones, and where you've got the South Atlantic anomaly moving it south, that knocks everything well south in South America, I believe, and you find that you have to look quite a way south to get back into it again.
Yeah. You have the geomagnetic dip in there, and
Yeah,
South
yeah.
America below the geometric equator.
Mm.
So, you know, a lot of people say, well, why don't you use the WSPR network? And I look at it, and it's good stuff, but it's almost all northern hemisphere centric. There's very little southern hemisphere stuff. So it's good stuff, but I just find the ionoson stuff better since I know how to interpret it and kind of map it into other things.
Yeah, no, interesting stuff, Ken. And don't want to hog it, but yeah, it's endless hours of fun with sporadic-E.
Oh yeah, it's kept me very busy in the last 30 years.
Ken, that was an excellent talk, by the way. I wanted to share one anecdote. It was when I first became a ham in 1976, and actually a year later, we were operating sporadic-E on 6 meters. It was amazing how far you could go per watt. I mean, I could work stations on the East Coast, you know, running 1 or 2 watts on. Watching Channel 2, which is a local Denver station here, and a lightning strike took Channel 2 off the air. And by Jove, we still had a signal on there after Channel 2 went off the air, and it was from Seattle. So I watched sporadic-E TV from Seattle for over 2 hours that summer afternoon. I thought that was cool. That's something that always stayed with me. A very memorable event, but it took a lightning strike to witness it.
Absolutely. Well, our ham career are full of such memories. And one I have, my father was a ham W2ZUM, and he still stayed on TV by antenna for a very long time. And one day I was visiting him in July, and I think it was 2009, and he was getting cross-channel interference all the way up to channel 7. So I said, gee, this is higher than 6 meters. It's probably approaching 2 meters. And I was right. I didn't have time to get much of a setup going, but I went to a parking lot. I had a quarter wave vertical for 2 meters, and I was just working these stations going up in volume and then dropping down. It was like working a wave almost. And there were stations I was working from Long Island into Florida and the Carolina area. So TV was a very good indicator, you know, back in the day.
We used to curse our Channel 2 in Boston area because in the old days, that was our basic problem with TVI and 6 meters.
Mm-hmm. Yep, I have a whole chapter of that in my book, the TVI band.
Yeah,
it's
you say up to channel 7, you probably mean channel 6. Channel 7 is high band.
Yeah.
174 megahertz.
Okay, well, it was approaching that, so
Yeah.
it might have even reached. It possibly could have reached 220. That's how strong this opening was.
Oh, that could be.
So it was. I could see traces of it though from 2, 4, 5, and it was showing up a bit on 7. So I'll never forget that.
I'm really. It's really too bad when they changed to digital from analog TV, because I live in a deep fringe area. I could get everything out of Boston, out through UHF, 100 miles out, and had a lot of low band TV interference. The furthest away I got to see was Terre Haute, Indiana, I think. Or no, there was a Fargo, North Dakota station I got in, but I think that was Aurora.
Well, yep, that's possible. If you heard distortion, yeah.
I was stationed at White Sands Missile Range in 64 to 66. And my friend and I had the car and he had the mobile radio. But we had 30 feet of short pieces of 3/4 inch pipe we screwed together and mounted on the back of the Corvair, parked it in a parking lot, put a 3-element beam on the top. Every time the FM band went crazy, the FM broadcast band in New Mexico, where we were, there were a couple of stations out of El Paso or whatever. But when sporadic-E came, the band was full. And we ran the battery down more than once.
That's fun.
But
One
Now
of
it's
the,
called AAA.
yeah,
Yeah. One of the problems I see, FT8 has kind of dominated 6 meters in the last 5 years. But there's a point, and it's great for very low signal strength type situations, like minus 10 dB and so on. But when you're getting readings up on the plus side, you should go on CW and sideband because it's very strong at that point. Why would you say on something that really is designed to measure weak stuff? And then you can have a normal conversation where you can at least exchange your name. So, which is
I have a question about
sure.
Working stations and countries. I'm trying to finish up a DXCC on 6 meters. I got 62 countries confirmed so far, but the last ones has slowed down to a crawl. I mean, I'm starting. Is it practical to try and do a DXCC on 6 without using moon bounce?
Oh yeah, for sure. It just takes a little while. I'm up to 98 right now, and that took me 30 years. The ideal place I think in the U.S. is the state of Maine because it's very good for F2 activity when it's not so great, and it's also good for that 3 hop into Europe in the summer. So I always thought of that as a good DX, and also southern Florida because you can get into trans-equatorial propagation. So I encourage my friend in Maine to rent out his cabin.
There's, by the way, a friend of mine has reported to me that there's been quite a bit of trans-equatorial this summer, or last summer and fall. On 6 meters.
Yeah, it doesn't take much to ionize the F layer over the equator. It's almost like a tropoduct, and so you don't need a tremendous amount of ionization there. As long as it's moderate solar activity, it can't be down in the low part of the cycle. But if it's moderate to high, yes, that's definitely true. So,
all right, we're getting near end time for the meeting today, as is normal. Any last minute quick questions for Ken? Otherwise, we may put a ribbon on it.
Yeah, if anybody has any detailed questions, my call sign is on qrz.com. It's ken.neubuck@gmail.com, but it's on the QRZ page as well. So I'm always happy to answer any questions you may have, because I think the more hams know, the better they can explain it to other people.
Well, would you repeat
Go ahead,
Sure.
Bob.
I was just going to ask him to please repeat his address.
Sure. It's Ken dot Neubuck @gmail.com.
Thank you.
I really had a pleasure speaking with you guys. I hope, it was a lot of good stuff that you either know or are interested to learn. So I really do appreciate the opportunity.
And thank you very much for taking the time, and not only to present, but also to prepare. This group is obviously definitely interested in propagation and whatnot. And you spoke about whisper a little bit earlier. We are doing a lot of work to increase the number of whisper transmissions. And there's a few people here on the call who are very adept at using the whisper and other spot data and extracting interesting information out of that data. And some of the new equipment we're working on as well to monitor the HF bands may well extend up into 6 meters. So we may be extending our reach a little bit. So I think there's a lot more to learn, and this group I think will help out quite a bit.
Very good. Well, thank you for inviting me. And like I said, I can answer any questions on email. So I appreciate the opportunity you gave me today.
Thank you.
Again, thank you.
And I want to thank you too, Ken. Thank you so much for coming on and for your good work.
Thank you.
Thank you, Ken.
Appreciate it. Thank you. All right, have a great day and great week.
Thank you, sir.
All right.
One quick announcement before we wrap up. I know a couple of us are going to stay on and talk about another activity here in HamSci, but be aware that the deadline for the abstract submissions for the workshop is February 10th, 4 days away. I'm about this close to getting my own abstract ready to be submitted too. And I see a number of the Scranton students have submitted theirs, and I think at least one from NJIT, if I remember. So it's good to see the participation there. So any last minute questions? Otherwise, I know Nathaniel, Mackenzie, and I want to talk about something for a little bit too, if that's okay. Okay, so far as next week, I got a few things up my sleeve, but nothing to announce yet. So we'll see what I pull out, what rabbit I pull out of the hat for next Wednesday. So thanks everyone for attending, and especially for everyone's participations. The questions and personal anecdotes make it a whole lot more interesting.
73.
73.
73.
Take care. Thanks so much.
Thank you.
73.